A short diary of Max Planck, Quantum Theory. 1900 February 26. Hi, my name is Max Planck. I just found a new theory that I have been researching and put a huge effort into it. I want to call it quantum theory. I use the black body theory, which is a theory that explains all the material absorb frequency of light. As a foundation of the theory, this theory is dedicated to the quantum theory, and I will explain all the information in this diary. 1900 March 1st. On this day, I focused on electromagnetic radiation. What is this? And how we connect it to quantum theory? We know that electromagnetic radiation, or ER, is a radiation that is all around us and takes many forms such as ultraviolet, radio wave, gamma ray, and many other things. So, how does it connect to the quantum mechanics? From the experiment I have done, we observed that electromagnetic radiation of given frequency can only be exchanged in quanta. Moreover, we can introduce photons with other smaller to create a more quantum of electromagnetic radiation. It is the basic unit of all light. Oh, it's late now. We will look at how to find energy of photon tomorrow. See ya! One day and one night pass. 1900 March 2nd.
Now, we will look at how to find the energy of a photon. We use the formula E equal to hv. E comes from the energy. H comes from the constant value, which is 6.63 times 10 power minus 34. For this constant value, it is a value that says how much the energy of a photon increases when the frequency of its electromagnetic wave increases by 1. And lastly, V is the frequency of the wave. When we calculate the energy value, it is in the joules unit. We can also find the energy from the wavelength we know by using the formula C equal to lambda, which is wavelength, times by nu, which is frequency. C is the speed of light, which has a constant value of 3 times 10 power 8. Another thing that we should know about frequency and wavelength is that it have an inversely relationship, which means that if it has many frequencies, the wavelength will be less. So how to find the energy of a photon? Let's look at the example questions. What is the energy of a photon with wavelength of 200 nanometers? First, let's state what we know. We know that lambda equal to 200 nanometers. But we don't want it to be nano, so we times 200 by 10 power minus 9. We also know the constant value of C, which is 3 times 10 power of 8. And we know the constant value of H, which is 6.63 times 10 power minus 34. Now, put what we know in the formula and calculate it. We will get the energy of a photon equals to 9.39 times 10 power minus 17.
First, let's look at the definition of the word quantum. It is a discrete quantity of energy proportional in magnitude to the frequency of the radiation it represents. And theory is a well-established explanation for scientific data. When we combine these two words together, we will get the definition that it is the theoretical basis of modern physics that explain the nature and behavior of matter and energy on the atomic and subatomic level. 1900 March 7. Today, I explained this theory to my friend, and they asked me a very interesting question. How the emission or absorption of photons result in changes in electron energy levels. And I think that I should write this point in the diary too. First, when a photon hits an atom, then the energy will transfer to the atom. We also have to know that electrons exist in discrete energy levels around the nucleus. And when the energy level is further from the nucleus, it will have a high energy. And when the atom absorbs photons resulting in electrons, so it can move to higher energy level. On the other hand, if an electron moves to a lower energy level or emits, it is called photon of light. Another point is that electrons only exist at energy levels where movement between energy levels result in emission or absorption of specific quanta of energy. 1900, March 9. Today, I found information about the study of emission and absorption of photons, an effect on electrons which is called spectroscopy. For calculation of difference in energy levels, we use a specific equation which can calculate energy emitted or absorbed as electrons moving between energy levels. So we will use the equation energy equal to Planck constant times width frequency. So this can calculate frequency of photons emitted or absorbed.
29 years later. 1929, April 11th. After I got the Nobel Prize in this theory, people applied the theory to many useful things. For example, night vision goggles. Night vision goggles help people to see things in the dark by using thermal imaging that's captured by infrared light. How infrared light works. Infrared can detect heat because every object on Earth emits infrared radiation in the form of heat. So we can observe heat by using infrared radiation, which is further developed to be night vision goggles. Night vision goggles work from radiation to the islands, which the islands convert radiation to electrons. Those electrons pass through many layers of cathodes, which produce more and more electrons and become clearer sights. At last, the last plate converts those electrons to photons, which make us see the night vision through the islands. This application led to our quantum theory, the photoelectric effect that was invented by Albert Einstein. The photoelectric effect stated that the light can neutralize the charge because the electron will convert it to be light, which we can see in the night vision goggles. Another thing that is useful based on the quantum theory is the Wi-Fi radiation, which is a non-ionizing wave or radiomagnetic wave that uses radio frequency to send signal and connect devices. It is about 2.4 to 5 gigahertz.
And this is our reference. Made by Grace, An, Sin, and Champu from 1111. Thank you for watching and hope you enjoy our video.